Assalamu alaikum wa rahmatullahi wa barakatuh. It's my pleasure to moderate this unique technical session about drones and robotics. And a very warm welcome to all our speakers and attendees joining us virtually from Saudi Arabia and across the globe. This session is part of the Project Execution Technology Conference organized by BMI Saudi chapter and strategically sponsored by Saudi Aramco projects team. I am Muhammad Shalan, working as the BMO Director for E-Enterprise at Umar Qasim Al-Isai Group and volunteering as the Digital Transformation Director for BMI Saudi chapter. In this session today, we will have three distinguished speakers. Our first speaker will be Mr. Alessandro Mania, who is the Sun Sub-Manager for Middle East at Saibem, promoting resident subsea systems and technologies to enhance digital transition of oil and gas clients to reduce cost, maximize uptime, and exploit the challenges of carbon footprint reduction. Welcome, Alessandro. Our second speaker will be Mr. Salah Al-Ghamidi, who is the Vice President for Adjacent Markets at Zain, responsible for launching several digital products and subsidiaries such as Yaqut Digital Telecom, Tamam Digital Microfinancing, and Zain Drone to provide related analytics and drone as a service. Welcome, Mr. Salah.
Welcome to everybody. Good morning.
Good morning. And our third speaker will be Mr. Saifat Hussein, who is a technologist working in the field of architecture, engineering, and construction, and advising key stakeholders of using cutting-edge technologies to deliver better design and construction projects. Saifat is a passionate advocate of digital construction, BIM, and reality capturing processes. Welcome, everyone.
Thank you, everybody, for joining us this morning. And today I will be talking more and to focus about how can we use drone as a service for project execution, which is a clear revolution on the project execution after what you will see on this presentation. First of all, on project management using drone as a service, what we are trying to achieve here is assuring faster data acquisition, better data acquisition and resolution and archiving, improve accessibility, increase a lot in cost efficiency, and for sure enhancing the safety of the people on the ground on these projects. By using those robotics remotely, we will gain a lot of these benefits. The presentation for Zain Drone today will be more of real-life examples of what we are talking about. So, starting from project planning phase on aerial survey, what you can see here is the huge difference on accuracy when we compare, for example, drone collected data with satellite collected data. Because as you can see here, we can really see a lot of details. This is the data collected by drone compared to the data collected by satellite, where we can absolutely see nothing when it comes to the exact details of the landscape. This is one of the benefits that can be generated at the beginning and the early phase of any project, especially if it's a giga project, piping for long hundreds of kilometers, or a similar kind of projects, entire base or industrial city. This kind of clarity and detailing will help a lot in the planning phase on all of the cost estimation, on all of the time estimation, on the scoping of the project, and will assure successful project planning and then successful project execution. Measurable 3D models can help a lot in measuring the progress monitoring of any project. This is an example where you can see details, the 3D model of progress based on data captured month after month, week after week, quarter after quarter, where a lot of the technical details and can help the project management team on acceptance or on providing the vendor with correction points before acceptance, and also it will measure accurately the percentage of progress on that huge project that they have. Another example is utilizing ortho-time labs for volumetric calculation to measure all the quantities on any site instead of utilizing human surveyors on the ground. That will help on accurately calculate all the consumed material. Also, it will show the differences, the rate, the run rate, and that will help also on the planning of the next shipment and so on. Another thing is for health and safety. For example, hazardous places can be accessed by a drone. This is a ground flare where the heat is huge and massive, so nobody can access it. However, by drone, we could access that from very long, very far away distance with detailed accuracy that can be collected. 3D time lapse also can be a good way for project documentation, and it's a good way to communicate the project progress with the management as well. As you can see in this example from ground up, how the 3D time lapse is showing the progress of the project. On inspection, this is this level of details that can be calculated from almost 100 meters away, utilizing detail, zoom in from the drone. Actually, this is collected from the same location, the same distance where this was collected from. So the drone couldn't fly inside anymore. However, the advanced cameras that we can use can actually bring us this kind of accuracy, even from that distance, to support on any inspection requirement that the customer might have. A lot of early adopters are there on the Kingdom of Saudi Arabia, including Aramco, of course, including Sadara, and a lot of other entities as well. So this technology is not, we're not talking about something that is futuristic and it's not here yet. The technology is available, the use cases are available, and the customers has already started utilizing that to achieve these goals. So what I'm happy about on this presentation today is to tell you that now we are talking about something very practical, something present. It's not something just a dream or something. So that's my presentation in a very short time. We try to keep it practical and to the point, just to show the audience here that drone and robotics are realistic, available, existing technology with a lot of use cases that's applied in the ground with a lot of customers within Saudi Arabia. Thank you very much for your time, and I think we're ready now for Q&A.
Thanks indeed, Mr. Salah, for this great presentation and the practical one, where you have touched on area surveys, you have touched on a lot of progress monitoring and a lot of services that's provided by a provider and a telecom provider. And my question to you is, why, for example, Azain as a telecom provider is entering this field as drone as a service, which is really very unique field and require a lot of operation and activities?
What we believe is in the next generation, especially with of drone, where the drone can be controlled remotely from a command center utilizing 5G network, then a huge strength of a telecom company will appear. Another thing, we are an ICT company. We have hosting, we have a lot of other services. So we have the hosting for the collected data. We have the software analytics for the collected footage. So we believe that as a telecom company, ICT company, we can provide 360 service where we can support on the data collection, on the data archiving, on the data analytics, and on the long-term data retention with all the services side. What we are thinking of the service in the future is to be more of a subscription base. So a client might have a subscription, monthly subscription to Drone as a Service kind of a product, and based on a monthly fee, retainer fee, and they will get all the services, including the hosting, including the software analytics, including the data collection itself, all based on a very light OpEx model.
Okay, so that's really very great. And okay, thanks indeed for this insightful presentation, Mr. Salah.
Really appreciate it, and we have a virtual booth. Please visit us.
Okay, virtually. Yes.
Yeah, thank you.
Okay, thank you very much. And now we are going to Mr. Zaifat Hussein about his presentation. Mr. Zaifat will be talking to us today about robotics in construction, quality and automation. And in this presentation, he will have a lot of insights related to how we are utilizing this kind of technologies into mobility and automation for laser scanners, as well for the technologies in project execution. It's you. Please go ahead, Mr. Zaifat. The floor is yours.
Thank you, Mr. Mohammed Salah. Thank you very much. Good morning, ladies and gentlemen. My name is Zaifat Hussein. This is my honor to speak alongside distinguished speakers and audience from the industry. Today, I'm going to speak about role of robotics, drone, and BIM technology in construction project execution.
Okay, Zaifat, please continue.
Okay.
The time is clicking.
Yes. So for few weeks before, I was sitting with one of my customer who was basically whose organization own hundreds of such large assets across the kingdom, like the one you are seeing on your screen. He asked me about the state-of-the-art solution for as-built verification. So the challenge is customer have as-built drawings, model informations, but that is not 100% updated. Doesn't every asset owner who are sitting in this presentation relate with themselves with this situation? So what could be the state-of-the-art solution? A solution with minimal or no human intervention in data collection and data interpretation. 3D laser scanning, a way of collecting the as-built data using different robotic devices and drone, as Mr. Salah has shown in his presentation. That is what I'm going to introduce you today during my presentation. As-built verification is one of the applications of 3D laser scanning, but there are a variety of other applications that can help us at different stage of project execution during construction, like on-site capturing, as-built model and design, quality control, design layout for data connect and share with the data with other stakeholders. These applications can help us doing this, utilizing this at different stage of the construction, like design stage, construction stage, and while we are going to operate the building at the facility management stage. There are 4 major steps in this process, divided into on-site and off-site processes. We capture the reality from the different position using our capturing devices, register those data captured from different position into the software. We clean and filter 3D point cloud and send them to BIM platforms or CAD platforms for further interpretation and data modeling and design based on industry. There are static scanners, indoor, outdoor mobile scanners, autonomous scanners, scanning solution fitted on drones, where Mr. Salah will be very interested, in fact, in such kind of things, and other people. We need the softwares that can register, process, and clean the captured data we collected using these scanners. The process 3D point cloud data can further utilize in variety of BIM or CAD platforms to create BIM model or generate drawings in Revit, CAD, some smart plant solutions from different software vendors. There are solutions available in the market which can help automate some part of this model making process. Also, we can analyze and compare captured data and design BIM models. Focus Swift is an indoor laser scanning solution developed using the static scanner and adding additional equipments to keep the track of data capturing while we are on move. The solution is 10 times faster than traditional static scanners and capture large and complex areas. You can always choose between quality and speed. You can easily switch between static and mobile scanners. You can always, this is very ideal for manufacturing facilities, for hospitals, and for large commercial buildings. So for a large facility where traditional static scanner may take up to 2 hours, Swift may complete the job in 8 minutes. Trek 3D is an autonomous 3D laser scanning solution. This brings together an autonomous solution integrating Boston Dynamics Spot robot and far-eye scanners. This is ideal for high-frequency scanning and on ongoing construction site for continuous progress monitoring of the site for construction quality control. This solution may also help us for as-built capture and digital twin solutions. We can program the mission for a spot and it will automate the data collection without human intervention. It can help reduce or mitigate human risk while scanning respiratory or chemical hazardous environment or oxygen depleted environment or old structure where there is a risk for collapse. This can help us maintain consistency in capturing. Integrating laser scanner with drone can bring you survey-grade accuracy. A solution integrating a purpose-built drone to carry focus laser scanner and other devices to report accurate results from a scanner. While the scanner is on fly, this gives us fully automatic flight trajectory and landing via iPad control station. It can give us...
Saifet, can I ask you just to conclude in a minute because we are running out of time?
Sure. It can give us relative accuracy up to 1 to 2 centimeter. We are using latest BIM technology to design our projects. Either it is BIM for building, infra, or plants. How can we verify the build that we design? So far, we saw how can we capture the reality, but how can we use that capture data for continuous construction verification? We can bring capture data and design data together and realize construction deviation. Either it is for a structure, for piping, for floor flatness, wall plumpness, volume computation, etc. This can help compare and update our final as-built drawing or BIM model that will be exact replica of our build asset. This will be your source of truth for a decade to come while you are going to operate and maintain the asset. Here is your first step towards the state-of-the-art solution for as-built verification with minimal or no human intervention. Thank you very much for your precious time. This was Yvette Hassan from Omnix International. You can capture this page and contact me later. We do have virtual booth at PETC and our experts will be happy to assist you. Thank you very much once again.
Thanks indeed, Saifet, for this interesting presentation. And to you, Alessandro, you have like 8 minutes only left. So please.
Yes, it's not a problem. Yes, it's not a problem. I'm just waiting for the presentation to pop out and I will start.
Yes, Kamel, you will share the presentation from your side.
Excellent. Thank you very much. So today, we can skip, since we are a bit limited on time, we can skip to slide number 3. Today, I would like to give you an overview of the potential applications of subsea resident technologies or drones. This one is perfect. So we're talking about environment subsea and application of resident autonomous vehicles and what are the benefits to project execution and life of fields. What we see today as a trend in the market is a shift of all the oil companies towards a reduction in operational expenditures, and so demanding of the operations offshore, a shift towards autonomous technologies. There is, moreover, the possibility with these robots, with these resident AUVs, to collect an immense amount of data that can be processed. to facilitate life extension of assets and to therefore optimize our capital OPEX balance. Moreover, less exposure of personnel offshore gives minimized standby, minimized exposure to harsh environment, therefore a bit of higher safety, lower carbon footprint, because with AUV resident technologies, you can save the vessel time of support offshore. Moreover, if you have resident technology subsea, this is a primer or an enabler to start shifting part of the P&ID that stays traditionally above water. You can shift it below water. We can see it better in the next slide. What are the benefits of resident technologies subsea? In particular, we can see here that if we can apply resident subsea technologies to our fields, there will be reduced offshore manning. The vessel spread that supports fields operations can be vastly optimized with a reduction in operational cost. At the same time, having resident technologies there gives a possibility of continuous data collection for an immense amount of data that is absolutely fundamental to start the proactive approach toward maintenance and potentially aiming at the predictive maintenance of our assets. And then we have also a very quick and prompt intervention in environments like sour environment, where on the contrary, manned solutions require a time to access the site. More than that, we believe that shifting the sustain and data collection and inspection and maintenance activities with resident technology subsea also allows to optimize the balance with the diving operations, enhancing safety. I included here in the next two slides a couple of state-of-the-art parameters of resident technologies as of today. For sure, we're looking at equipment that have hovering capacity, so can stay fixed subsea in a position, a enhanced capability of payload in terms of survey sensors, but also manipulation capabilities like a traditional ROV, an extended autonomy that must exceed and currently is exceeding 100 kilometers, and significant artificial intelligence capabilities. These systems are, as of today, capable of tracking their route along pipelines, identifying defects, identifying subsea features like anodes. I continue in the next slide with a different set of requirements and also with the current benchmark of the subsea market. In particular, it is interesting to understand that in this moment, there are several ways of thinking about the deployment of these assets that can be deployed from a jacket, from an FPSO, or can be resident subsea with their own garage where we provide power supply. The last slide is very interesting, provides a summary of all the potential savings that have been already verified on the field. First of all is the reduction in a carbon footprint, because we avoid or we minimize the impact of the vessels offshore. We reduce the manning offshore by 70%. This is due to the fact that we cannot get rid of all the people offshore. There are still people that need to support these operations. And more than that, we have already evaluated in many fields around the world an enhanced reliability of the system and an availability of the field in the terms of 0.1 to 0.5%, which seems very low, but always remember we're talking about an entire field, which means 1 to 3 days of production more every year. This concludes my overview of the technologies, and thank you very much for the time you allotted.
Thank you very much for this presentation. And I have one very quick question to you, actually. How you see the maturity of these technologies today?
Incredibly mature. I can tell you that there are some companies like Equinor that are at the forefront of the application. We as Saipem are providing to them already a resident subsea system. But there are many other companies that are actively pursuing, especially studies of integration of this phase, especially in Western Africa and in South America. They are very much mature. What I'm showing here to you as parameters are parameters of things that are in this moment running on the field, not something that we see behind the horizon.
Okay, thanks indeed. Thanks indeed for this insightful presentations.
Thanks to you, Maria.
And in spite of some technical difficulties, thank you really indeed, and it was really very interesting. In this closing, I would like to thank you, the speakers, for sharing wealth knowledge from real experience in a professional manner with this limited time slot. And also, today's session was very interesting, and we have covered real experiences from the field using drones and robotics to achieve a revolution in smart execution. And finally, I would like to thank all our attendees who are watching this session virtually from multiple locations, and even to thank the people who will be watching this session recording after a few days. Thank you very much, and looking forward to see you in another event. And thanks for the BMI and Aramco for this event. Thank you.